Okay, so what we have to discuss today is basically different subsystems or subparts of uh, steam power plant. So basically, we shall be focusing on different aspects. And if you see this diagram, we can understand. Probably we discussed it as well, a little bit of it. We also shared some video that was actually showing the simulation of a thermal power plant, steam power plant. So as you can see that there are some sections called coal handling plant, so coal storage, coal handling plant, ash handling, then the boiler system, then we have electrical system here, this side, and similarly we have the cooling tower and of course the pollution uh, removal or at least pollution suppressant. So all these things we shall discuss one by one. So first thing that we start today is the fuel and ash circuit, that is the coal and ash handling part. So basically, make it a little bit. Yeah. When you see fuel and ash circuit, so coal is delivered from the supply point to the storage site by road, rail, or water. By road, coal is transported in trucks, and for the small stations such as inland transport may be enough. Whereas power plants are suited close to waterways such as canal, river, or sea transportation by boat or ship may be quite effective. So that is actually your discussion about the transportation options. So the transportation options are generally by trucks or rail. Railway is one of the you can say most important factor or most important way of transportation of coal, and but there could be waterways as well. आजकल वाटरवेज तो बहुत ज़्यादा नहीं होती है, हालांकि जब रेलवे इतना ज़्यादा वाइड स्प्रेड नहीं था तो वाटरवेज एक इन हिंदुस्तान में एक तरीका होता था पानी से आने और जाने का, और इवन नाउ इट कुड बी एन ऑप्शन, स्पेशली जो प्लेन एरियाज होते हैं, क्योंकि प्लेन एरियाज में प्लेन जो रिवर्स होते हैं, प्लेन एरियाज के जो रिवर्स होते हैं उसमें बहुत ज़्यादा ऊंची नीची ज़मीन नहीं होती है, तो उसमें वाटर के ज़रिए भी ट्रांसपोर्टेशन हो सकता है। अभी आपने रिसेंटली देखा भी होगा कि किस तरह से प्रयागराज से और वाराणसी तक जो है वो वाटरवेज खुले भी हैं, यानी उसके ज़रिए भी लोग ट्रैवल कर सकते हैं। So this is not only up to Varanasi; it could even go up to Kolkata, and it can start from Haridwar. If you talk about the Ganga river system, so the waterways could always be a good option. But recently, after many what we call dams and bridges built over the way, sometimes it becomes difficult. But earlier it used to be a good option of traveling through waterways, canals, rivers transportation, and of course by the sea. You must be aware that most of the transportation of uh, fuel or even the goods and services, not services, goods, especially the supply of what we call grains and finished and unfinished products, which is transported between China, Africa, India, Europe, America. Mostly it is done by sea travel. And in our context, we discussed about the coal being transported from Australia, and we I gave another country name. Do you remember, any one of you? Which country apart from Australia we get coal from? ऑस्ट्रेलिया के अलावा किसी को पता है कौन सा जगह है जहाँ से कोयला लेते हैं हम लोग? एनी आइडिया? Okay, it is Indonesia. So we get a good amount of coal from Australia and Indonesia. So that is of course done by waterways, meaning sea. So we may not be good with the waterways during yani through rivers, but sea is still the largest proportion of transportation between countries, and that is fairly because of 70% of the Earth is actually water. So definitely the waterways and the communication between uh, foreign countries are still good with waters. We say. Now, in case of a small power plant, the quantity of coal being small, manual unloading from rail car may be used. But for large power station, the unloading from the railway siding is done with the help of wagon triplers, and then the coal is converted to the coal handling plant. Now, from the coal handling plant, the coal, having been good enough to be burned in the boilers, is taken into the boiler bunker by means of bucket conveyor. So, I think we showed some images that how conveyor belt is being used or are used to transfer coal from one place to another place, especially
इसमें वो
to the boiler.
डिस्टर्बेंस आ रही है सर
कुछ कह रहे हैं? जी.
सर आपकी वॉइस में वो डिस्टर्बेंस आ रही है
अच्छा, किस तरह की डिस्टर्बेंस?
सर जैसे
साउंड
रेडियो में
और
जब ट्यूनिंग करते
टेक्निकल
हैं
इशू?
तो वैसे ही आती है
ओ ओ ओ, अच्छा अच्छा अच्छा, ठीक है. Okay, it is maybe because of movement of the wire. I'll try to minimize it as much as possible. Let me know if it comes again.
सर अभी भी आ रहा
So maybe I think strange. For small, of course, it can be done by individuals, but then for when it comes to uh, bigger power plants, then we got to have some wagon triggers, and then it is conveyed through what we call conveyor belts. So let me just search for just to see it. Yeah. It's good that it's readily available. Then how can we see the images of it? So you can see some of the examples.
Excuse me, sir.
Uh, some of the examples are like this. This is how the conveyor belts are can be transferred. Some of the images of the coal, pulverized coal. But as for and this is also a good way of you can see it. It's a conveyor belt again. It is directly coming from the coal, then it is going up. It is going directly to the power plant. So this could be steel spiral conveyor coal belt. So it is just giving the cost, etc. But of course, for our purposes, we can actually understand that how conveyor belts look like, especially the coal conveyor belts. And there was another term which we just said, we was triplings, wagon triplers. So how does it look like? Yeah, this is how you can see it. The whole uh, wagon is actually can be picked up, and all its coal can be taken out, and then it can be put back to the place. So a lot of images are there. You can see it. So this is how it looks like, wagon triple S. So it's a huge machine and seems like a toy, एक खिलौने की तरह से उसको उठा के और उसमें से सारा कोयला निकाल लेना है और फिर वापस उसको रख देना है. So that is of course required when it comes to a higher amount of uh, coal that has to be taken out. Okay, now getting ahead, The coal is thus stored in the bunker from where it falls into the hoppers by gravity, and finally the requisite quantity of the coal either goes to the falling directly or the grate, or where the coal spear spreaders are provided. Coal is spread in the grate up to the rear end. When use of the spreaders is made, most of the coal burns in air and remaining falls at the rear end of the grate. Any unburnt coal particle in the middle of the grate are collected in the pipe and are again refired by cylinder refiring fan. Okay, so we understand that there are fans to provide enough amount of oxygen, and if grate is something where a small amount can fall down, and then it can be put back for firing after pulverizing. The grate in such type of boilers where used of spreaders is made move from rear end to front end, and without spreaders, the movement of the grate is from front to rear end. Combustion is controlled by controlling the grate speed, quantity of coal entering the grate, the dampers opening. Okay, so I hope now you can understand that how the combustion is controlled is amount of coal you want to put inside, and that is controlled by the speed of the machine which is going into, which is known as grate, and the quantity of coal entering the grate, and it is also used by the dampers opening, yani how much is the what you call circumference of the grate which is going inside, and the speed. So one is the speed and one is amount circumference of the grate. So in both the cases, of course, we understand if the speed is more and even the opening is small, still more coal can go inside. So first we can do what we can do is either we can control by slowing down the speed, or we can uh, shorten the circumference of the opening. So damper opening. The ash resulting from complete combustion of fuel collects at the back of the boiler and is removed to the ash storage by means of scrap conveyors. So one conveyor belt was for coal and one conveyor belt is for ash, which is ash we understand once it is burned, whatever is remaining after much of the thing has been burned, a lot of ashes and pollutants go to the chimney. Some of them are filtered with the help of pollution suppressant elements, and whatever is left there is of course ash uh, that can be stored somewhere outside this whole boiler system. And I think we did studied about it, that there should be some storage place, and a lot of storage place where either it can be used for making of the bricks, or it can be simply put inside the earth by digging up and putting the ash inside, and then the covering up. So that could also be option, or it could be sent back to the uh, the place from where it was digged out. The coal was digged out, yani the mines. Okay, so that was the first thing. Then there is a air and fuel gas circuit. How the air and fuel is supplied. So air is drawn from the atmosphere. That's very clear. And to put the more of oxygen to that, we can actually use a draught fan. By a forced draught fan or induced draught fan through the air preheated, in which it is heated by the heat of the flue gases. Preheater is something that air which is passed through the flue gases. So that air will already be at some heat. So that will improve the efficiency of the whole process, in which it is heated by the heat of the flue gases passing to chimney and then admitted to furnaces. The flue gases, after passing around boilers tube and superheaters tubes, are drawn by induced draught fan through dust collector or precipitator, economizer, and air preheater यानी these are the यानी one by one. First, dust collector or precipitators. So dust collector or precipitators is actually the pollutant suppressant. Then it goes to economizer, then to the air preheater, and finally exhausted to the atmosphere through chimney. So before going to in the atmosphere through chimney, it goes through these three things. पहले डस्ट कलेक्टर के पास जाता है, इकोनोमाइजर्स के पास जाता है जो वाटर को हीट करता है, और फिर एयर प्री हीटर को जाता है जो एयर को हीट करता है, और जो कि यानी वो एयर जो ऑक्सीजन को सप्लाई करता है, बर्निंग को जो सपोर्ट करता है. सो वार्मर द एयर एंटरिंग इनटू द बॉयलर बेटर द यानी बेटर द व्हाट वी कॉल जो कभी कभी नमी हो जाती है वो इन चीज़ों से एकदम से ख़त्म हो जाती है, उसकी वैल्यू बढ़ जाती है यानी. Okay, so now we come to the feed water and the steam circuit. That's the third part. The steam coming out of the turbine is condensed, and the condensed is extracted from the condenser by condensate extraction pump and is forced to low pressure feed water heaters, usually three in numbers, whereas temperature is raised by the heat and blade system. Steam extracted from the lowest pressure extracted point of the turbine. The feed water is now pumped through deaerator to high pressure feed waters, usually two or three in numbers, where it gets heated by the heat from the blade steam extracted is suitable for the steam turbine. The function of deaerator is to reduce dissolved oxygen content into the condensate. The feed water is then pumped into the boiler through economizer in which it will be further heated by वही जो बात हमने ऊपर रखी थी किस तरह से economizer में दोबारा से पानी को गर्म करता है. So that is how it whole process. A small part, about 1% of the steam and water, is passing through the different components of the system is lost. Therefore, water is added in feed water system and makeup water. In boiler water is converted into high pressure steam, which is good. I think we have read already on this whole process. So just a simple reading of this will give you the idea that how it's the whole process. हमने इसको भी समझ लिया है ये जो पूरा प्रोसेस है किस तरह से फ्लो होता है, और हमने जो उस पर वीडियो भी एक देखा है. तो आई थिंक दिस विल बी क्लियर. अगर इसमें से कोई सवाल हो तो आप हैंड रेज कर दें, तो फिर मैं आपको अगर कोई स्पेसिफिक सवाल हो तो उस पर हम बात कर सकते हैं. No hand raise here. Okay, so then the fourth point is cooling water circuit. This cooling water is supplied from natural source of supply such as river, canal, sea, or lake, or cooling towers through screens to remove the matter that might choke the condenser tube. Okay, so the purpose of the cooling tower is to screen is through screen to remove the matter yani the pollutants that might choke the condenser tube. अगर इसको ले जाएंगे तो फिर condenser tube को choke कर देगा. It is circulated through the condenser. Through the condenser for condensing the steam and finally discharged to the suitable position near the source of supply. During the passage, its temperature rises, and in the case of cooling towers, the heat must be extracted before the water is again pumped to the condenser. The circulation of cooling water to the condenser helps in maintaining a low pressure in the condenser. इसी चीज़ को एक यानी इस तरह से भी रिप्रेजेंट किया गया है कि इसमें कौन सी चीज़ क्या है. हालांकि इसको इसका रिप्रेजेंटेशन यहाँ पे हो चुका है, बट ठीक है, just for a better understanding we can even look to this as well. So if you see this, you can see इसमें कुछ चीज़ें तो आप एकदम से पहचान सकते हैं कि जो कूलिंग टावर कौन सा है, चिमनी कौन सा है, बॉयलर कहाँ पे है, इलेक्ट्रिसिटी सप्लाई कहाँ पे हो रही है, जो टरबाइन कहाँ है, जनरेटर कहाँ है. So और बॉयलर कहाँ है, ये सारी चीज़ें आप देख सकते हैं. बट जस्ट टू गेट द एग्जैक्ट डिटेल्स, the first where it is written, that is the cooling tower, second is cooling water pump, third is transmission line, fourth is transformer. So transformer जाहिर सी बात है स्टेप अप ट्रांसफार्मर होगा, क्योंकि जो जनरेशन होती है वो जनरली 11,000 पे या 6.5 पे या फिर और किसी वोल्टेज पे भी हो सकती है, बट जनरली ये 11,000 या 6.5 में होती है. तो जाहिर बात है जब हम इसको सप्लाई करेंगे तो इसी सेम वोल्टेज पे तो सप्लाई करेंगे नहीं 11,000 पे, कम से कम तो 66 अगर बहुत दूर नहीं जा रहा है पावर तो, या अगर बहुत दूर ले जाना है, या अगर HVDC है तो फिर उसी हिसाब से हमें वोल्टेज को अप करना पड़ सकता है. जो 220 किलो वोल्ट हो सकता है, 400 किलो वोल्ट हो सकता है, 760 किलो वोल्ट हो सकता है, 56 और 1200 किलो वोल्ट भी हो सकता है डीसी के उसमें. तो इसके लिए ट्रांसफार्मर की ज़रूरत पड़ेगी. देन वी हैव थर्ड इज ट्रांसफार्मर लाइन है, अच्छा ट्रांसमिशन लाइन है. फोर्थ इज ट्रांसफार्मर है, थ्री फेज. फोर्थ फोर्थ इज यूनिट ट्रांसफार्मर है. फिफ्थ है इलेक्ट्रिक जनरेटर. सो यू कैन सी फिफ्थ कहाँ पे है, इलेक्ट्रिक जनरेटर. उसके जस्ट पीछे जो है 6 पे लो प्रेशर टर्बाइन है, 7 पे बॉयलर फीड पंप है, 8 पे कंडेंसर है, 9 पे प्रेशर टर्बाइन है, 10 पे गवर्नर वॉल्व है. So if you can see 10 is the governor wall, यानी how much working fluid has to be let into, that is the 10, which is steam governor valve. Then we have high pressure turbine 11. ठीक है, दो टर्बाइन इसमें शो किए गए हैं, हाई प्रेशर टर्बाइन और लो प्रेशर टर्बाइन. डीएरेटर 12, 13 फीड हीटर, coal conveyor, coal hopper, pulverized fuel mill, boiler drum, ash hopper, superheater, core exhaust fan, reheater, air intake, economizer, air preheater, precipitator, induced draft fan, chimney. तो ये आप कह सकते हैं कि जो पार्ट्स ऑफ कोल फायर्ड स्टीम पावर प्लांट है वो ये 27 है. इनमें इनके डिटेल्स जो है ये एक लेआउट है, यानी एक अलग फॉर्मेट में है किस तरह से, उसी चीज़ को यहाँ पे लेआउट के जरिए बॉयलर, अल्टरनेटर, कंडेंसर. ठीक है, ये एक सिंगल लाइन इसको कहते हैं साइड व्यू. जो ऊपर लिखा ऊपर का जो फिगर है साइड व्यू है, और उसके नीचे का जो व्यू है वो टॉप व्यू है. ठीक है, तो इस तरह से भी हम देख सकते हैं एक लेआउट है, एग्जैक्ट जो डिज़ाइन होता है किसी भी सिस्टम का. तो वो चीज़ें आप यहाँ पे देख सकते हैं. मेरे ख्याल से बहुत रिलेवेंट नहीं है हमारे लिए, हम इसको स्किप कर सकते हैं, बट स्टिल फॉर अंडरस्टैंडिंग यू कैन अंडरस्टैंड. अब जो इसके अलग अलग पार्ट्स हैं, ऊपर तो जो सिस्टम्स थे, अब इसमें पार्ट्स के डिटेल्स के बारे में डिस्कशन है. तो सबसे पहले जो डिस्कशन है वो स्टीम जनरेटिंग इक्विपमेंट. स्टीम को जनरेट करने के लिए क्या क्या चाहिए, तो ए बॉयलर चाहिए, बॉयलर, बी बॉयलर फर्नास चाहिए, तीसरा सी सुपर हीटर एंड री हीटर्स चाहिए. देन वी हैव इकोनोमाइजर एंड एयर प्री हीटर चाहिए, और एयर प्री हीटर ये इतनी चीज़ें चाहिए हमें अपने फर्स्ट जो हमारा सिस्टम है, सब सिस्टम है, जिसको आप कहेंगे स्टीम जनरेटिंग इक्विपमेंट. सो वी ट्राई टू कवर एज मच एज पॉसिबल टुडे इन दिस स्टीम जनरेटिंग इक्विपमेंट. फर्स्ट थिंग व्हिच इज okay, I think now it's clear. अच्छी बात है. So the first thing is that boilers. boiler is quite understandably it's something which boils water or it generates steam by converting the water into steam. And from one of the major equipments in the steam power plant, boilers used in steam power plant are of two types, namely fire tube boilers and water tube boilers. In fire tube boilers, the tube containing hot gases of combustion inside are surrounded with water, while in water tube boilers, water is inside the tube. ठीक है, तो एक में पानी बाहर है और एक में गैस बाहर है. ठीक है, so that on the basis of this, the two types of boilers are called fire tube boilers और water tube boilers. एक में अंदर फायर है, ट्यूब के अंदर, बाहर वाटर है, और एक में हाँ अंदर वाटर है और बाहर फायर है. So we got to disconnect these two for obvious reasons, क्योंकि पानी जो है आपको बुझा देती है. तो अगर आप पानी और आग को एक साथ कहीं पे भी ले जाएंगे तो वो एक दूसरे को कट आउट करेंगे, यानी क्रॉस करेंगे, और जिससे कि क्या होगा कि वो बुझ जाएगा पानी. सो बट हमारा काम ये है कि हम पानी से उसकी गर्मी तो लें, लेकिन उसकी जो भिगाने की जो प्रॉपर्टी है, the property to drizzle or douse fire, that we don't want to take. So we only want to take the what you call उसकी गर्मी लेना चाह रहे हैं. We want to take only the heat, not the water out of it. Water is a conductor of heat, so we boil it and yani we transfer the heat from air to the water, but you don't want to directly connect. So this लिए या तो किसी एक को ट्यूब में होना ही चाहिए. So either you put the fire in the tube or you put the water in the tube, and basis of what you do is actually the type of boiler is designated upon. In fire tube boilers, the tube contains hot gases of combustion inside the surrounding and water, while in water tube boilers, the water is inside the tube and hot gases are outside the tube. ये थोड़ा इसको बड़ा कर. Fire tube boilers are compact in size, have low initial cost, and have ability to raise rapidly large quantities of steam per unit area of fire weight, but have to follow the following drawbacks. As water and steam both are in small shell, higher pressure and higher volume of steam are required to raise the quantity of steam per area. ये बात चल रही है फायर ट्यूब बॉयलर्स. ठीक है, इसके अंदर ट्यूब के अंदर फायर है. एंड सो इसमें एक प्रॉब्लम ये है कि इसकी प्रेशर को बहुत ज़्यादा नहीं बढ़ा सकते. एंड विद अ कैपेसिटी ऑफ 15,000 किलोग्राम ऑफ स्टीम पर आवर, for higher pressure or higher rate of evaporation, the cell and fire tube boilers become extremely heavy and unwieldy. In the event of the sudden major tube failure, steam explosion may cause in the furnace due to rush of high pressure water into hot combustion chamber, which may generate large quantities of steam in the furnace. यानी अगर ट्यूब टूटा तो क्या होगा? That's a in simple words, that's the issue. ट्यूब में अगर हम गैस को ट्यूब में अगर हम फायर लेके चलेंगे तो that is why fire tube boilers use is therefore limited to low cost, small size and low pressure plant. ये इसका डिसएडवांटेज है. उसको हाई प्रेशर पे हम नहीं चला सकते, और इसलिए लो कॉस्ट और लो साइज लो प्रेशर प्लांट के लिए ही यूज होता है. फॉर सेंट्रल स्टीम, जस्ट अ मिनट प्लीज. Okay. For central steam power plants of large capacity, water tube boilers are used. Water tube boilers essentially consist of drums and tubes. The tubes are always external to drum. The tubes are always external to drum. In comparison to fire tube boilers, the drum in which boilers do not contain any tubular heating surface. So they can be built in a smaller diameter, and consequently they will withstand high pressure. The water tube boilers have got following advantage over the fire tube boilers. So that is something which we can focus on. वाटर ट्यूब में क्या एडवांटेजेस हैं जो कि फायर ट्यूब में डिसएडवांटेज था. इसमें हाई इवेपोरेशन कैपेसिटी है ड्यू टू अवेलेबिलिटी ऑफ लार्ज सरफेस एरिया, better heat transfer to the mass of water, and better efficiency of the plant owing to rapid and uniform circulation of water in tubes. ऐसा नहीं होगा कि कहीं एक जगह ज़्यादा गर्मी है और एक जगह कम है, जो कि एयर के केस में हो सकता है. वाटर के केस में ये ज़्यादा रैपिड होता है, यानी दोनों ही कंडक्ट करते हैं हीट को, बट जो वाटर की जो कैपेसिटी है, प्रॉपर्टी है हीट को कैरी करने की, वो ज़्यादा रैपिड है और ज़्यादा यूनिफॉर्म है एज कम्पेयर टू एयर. So that is an advantage, better heat transfer of the mass of water. Now high working pressure due to small size of drum. इसका ड्रम साइज उतना बड़ा नहीं होता, तो इसलिए इसकी प्रेशर जो है हैंडलिंग कैपेसिटी भी ज़्यादा है. Quick raising of steam owing to large ratio of heating surface of water volume. जल्दी गर्म हो जाता है. Quick raising जल्दी यानी स्टीम प्रोड्यूस करने लगता है. Safety in operation. Safety, of course, it's a comparative issue, it's a relative issue as compared to the air tube boilers. Space involved भी कम है इसमें, better overall control and easy removal of the scale from inside the tube. The design of boiler depends upon several service factors such as weight, height, portability, safety, bulk, character of operating labels, life, efficiency, and cost. The boiler may be straight or bent tube of diameter ranging from 25 millimeter to 100 millimeter, longitudinal or cross-drum, horizontal, vertical, or inclined tube. Forced or natural circulation, single or multi-drum, sectional or box under, cross or parallel bucket. So lot of options we have been given कि कितने तरीके से उसकी आर्किटेक्चर को अरेंज किया जा सकता है. Stationary, marine, header boilers using a straight tube have been superseded by curved tube drum type. Natural circulation by density difference of water is employed with pressure up to 175 kg per centimeter square. Pumps giving control circulation are often preferred. On design delivery, more than 340,000 kg of steam per hour at pressure of about 100 kg per centimeter square. Okay, so here is one important point. ऊपर से भी data है. Research and development during last 60 years has led to large steam generating capacity boilers having improved design and construction. Today boilers are more efficient, compact, and lighter in weight in comparison to old-time boilers, and can burn low-grade fuels. ठीक है, तो ये एक अच्छी चीज़ है कि ये लो ग्रेड जो कि हिंदुस्तान के ज़्यादातर boileries में है. It's not a very high grade fuels, but then recent technologies and developments have made it possible to use even low grade fuels. Supercritical pressure boilers with pressure as high as 750 atmosphere temperature, 600 degrees centigrade, and capacity of 1 lakh kilogram per hour available nowadays. So these are some we can say constraints or some characteristics, what we call technical specifications. Pressure जो है 350 एटमॉस्फेयर, 600 डिग्री सेंटीग्रेड और 1 lakh kilogram per hour. This is the capacity of water that carries. Selection of size and the type of the boiler depend upon first, यानी कि इतने सारे जो ऑप्शंस अभी गिनाए गए हैं उसमें से कौन सा टाइप ऑफ बॉयलर ठीक रहता है, या बेसिस क्या होगी जिस बेसिस पे हम ये चुनेंगे कि कौन सा बॉयलर लिया जाए. सो द आउटपुट रिक्वायर्ड कितना चाहिए, ज़्यादा चाहिए कि कम चाहिए, एंड दैट इज ऑन द बेसिस ऑफ स्टीम ऑफ एन अमाउंट ऑफ स्टीम पर आवर. यह बात है, उसी से डिपेंड करेगा कि कितनी ज़्यादा स्टीम ज़्यादा जाएगी तो ज़्यादा बड़ा सिस्टम है, ज़्यादा जनरेशन करेगा. कम है तो कम जाएगा तो कम जनरेट करेगा. उसी हिसाब से कम स्टीम जाने का मतलब है कि छोटे टर्बाइन से. Operating temperature and pressure, availability of fuel and water. Third, the probable load factor. The other factor, load factors हमने पीछे पढ़ा था. The other factor which influences the choice of the boilers are availability, कॉस्ट, इनिशियल कॉस्ट, जाहिर बात है इनिशियल कॉस्ट की ही बात इसमें इम्पोर्टेंट है। फिर मेंटेनेंस कॉस्ट जो ओवर द पीरियड आएगी, लेबर कॉस्ट, फ्यूल कॉस्ट एंड स्पेस रिक्वायरमेंट। So these are the some conditions which we can use to understand that which one is better. The noteworthy point is that the total cost of the fuel used by the boiler in its lifetime may be 3 to 4 times in the initial investment. तो ये टोटल कॉस्ट ऑफ फ्यूल जो होगा अपनी पूरी ज़िंदगी में वो इनिशियल इन्वेस्टमेंट के 3 से 4 टाइम में। एनीवे दिस इज ऑफ कोर्स अंडरस्टैंडेबल कि जो रनिंग कॉस्ट है वो कोयले का ही है। कोयला जैसे जैसे गर्म होगा यानी यूज़ होगा उतना ज़्यादा वो कॉस्ट मिलेगा। सो इस लाइफ टाइम 3 से 4 टाइम इनिशियल इन्वेस्टमेंट से अंडरस्टैंडेबल। खैर इसमें और कोई पॉइंट है? If you want to ask second point, boiler furnace we will discuss tomorrow. अगर इसमें कोई सवाल है आप लोगों का तो आप कह सकते हैं। Any raising of the hands? Any question? Okay, so Rohit, are you there?
Yes, sir.
Rohit?
Hello.
I'm not able to hear you. I don't know what has happened. Anyway, you just take the attendance and send me as you have been sending earlier.